Well, good. Well, thank you so much for being here, one of the last session of the conference. So I really appreciate it and very happy to be here. Thanks for having me at DevOps Friends. And my name is Ray. I am a developer advocate for the Google Cloud Platform. What that means is I like to bring some of the latest and greatest technology from Google to developers all over the world. And the other side of the job that people don't see is I actually like to collect a lot of the feedback and understand how people are using our technology or what they want in our platforms. And I try to influence and make our products better. So if you have any suggestions, any ideas, any feedback, please contact me on my Twitter at Satanism. Okay. And aside from developing applications on the side and also being an architect for a while, long time ago, and consulting and all that, aside from technology, I love to travel. And that's a photo of me traveling around the world somewhere, in a desert somewhere in this case. And yeah, if you like to see where I go, try to see my photos on Flickr. All right. So today, what I'm going to talk about is actually a little bit about Kubernetes. Now, before the session, I did a little poll, and it seems like only about 2 people have used it. So I'm going to go slightly more on the introductory part of it. And then at the end of it, what I want to show you is the real power of it, where you can actually deploy and manage and develop, like, say, a microservice application or just a monolith. It doesn't matter. You can manage this from your laptop. To do all of the initial development, and then you can move the same workload to the cloud or in your own data center. And then even more is you can actually, with the same platform from your laptop, you can then deploy everything to a global network, a global data center around the world, okay? So what is Kubernetes? Kubernetes is an open source project that was created originally by Google, but now it's actually owned by the Cloud Native Foundation. And it is designed to help you orchestrate and manage containers. So how many people here are using Docker containers today? Yeah, everyone, yeah. How many people are managing it with shell scripts? No, yeah, there's people like, I don't want to put my hand up, it's okay. Yeah, but there are a few, right? It's what I've seen in some cases where I talk to customers like, hey, how are you managing your containers today? Is that, well, you know, we will package everything in a container, and then we're going to SSH into our machines and do a Docker run, right? And then magically, somehow, it used up all of the file system spaces because all the containers are still there. I don't know if anyone had that happen to you, but if you did, let me know. I'll tell you how to solve it, right? But that's not how we deal with containers at scale, right? And that's where orchestrations come in, where we can actually help you manage the deployment of your containers across an entire cluster. And that's what Kubernetes was designed to do. And I was using Google's experience in managing containers for a very long time. In fact, Google committed one of the first container, the fundamental technology for containers, which is called C groups, into the Linux kernel a while back. And that is one of the fundamental technology that people use to build their containerized system today. Okay? Now at Google, we launch about 2 billion containers per week, right? Everything at Google runs in containers. And we have an internal system called Borg that helps us orchestrate it. And we took that experience, and then we open sourced a new system called Kubernetes. And the same engineers who actually work on Borg work on Kubernetes as well. And this is essentially how it works behind the scenes, right? Rather than having you to go to each of the individual machines to deploy your app, this is what we do in Google with Borg, and this is what you can do with Kubernetes today, which is to containerize your app, which become a static binary of some sort that has a runtime in the app, and then you push it to a registry, like a Docker registry of some sort. And then you can write a configuration file that will declare what this application should look like in the deploy state. So what that means is, what images should I be running? How many instances should I have? And also, what kind of health checking do I need? What kind of configuration should I have for this application when it's running? You just write a configuration file, and then you push it to the Kubernetes Master. And the master node will then be able to manage your entire cluster from there, right? So the master node will have access to, for example, like 10 nodes or 20 nodes. In Kubernetes 1.6, which just came out last week, we can go up to 5,000 nodes. So in a single cluster, you can manage up to 5,000 machines. And what Kubernetes Master can do is, once you give it the configuration file, it's going to say, oh, so you need 10 instances of my microservice application. Let me go ahead and find the resource for you. So it's going to check with the machines to say, hey, do you have enough capacity to run this app? How much memory, how much this do you need, or how much CPU do you need? And then if you have the capacity, it's going to say, okay, machine number 1002, go ahead and download the Docker image and start the container for you. Okay? And in Google, we do very similar mechanism with Borg, and we can start up about like 1,000 instances in about 2.5 minutes or so, right? But that's a combination of our software and the networking. In Kubernetes, I don't know what the SLA is, but you're able to start up plenty of containers in a fairly short time as well. Okay. So the real power here, without going into too much detail here, is that the real power is, remember the days where you have a project, like a project manager comes to you and say, we have a project we need to create, we need to finish in a year. But I don't know what it is yet, but how many machines do you need? Right? Like, why do we need to start out that process so early? It's mostly because it takes so long to procure the physical machines, to cable it, and also to, somebody actually has shipped it in a container to your data center and all that. And finally, once the machine is cabled and connected, what do we need to do? We need to install it. We need to set it up, right? And the way we set it up is there's this long and complicated instructions, a document somewhere, where you say, okay, here's the IP address, here's the host name, here's the package, here's the operating system. Go put Tomcat on it, and use this Tomcat XML, and run on this port, right? And then set up these connections and URLs and, I don't know, GND, and then open up the firewall, blah, blah, blah. And then you do this for every machine. How many people have to go through that sometimes? Yeah, a few. It's okay. Yeah, people do this all the time, right? And then what happens? If you have multiple applications running on the same machine, what do? Well, that's too bad. You cannot run multiple applications on the same port, right? So what do we end up doing? On the machine, we say, okay, port 8080 goes to instance number 1, port 8081 goes to instance number 2, blah, blah, blah. Then you have a giant spreadsheet. And then what do? And then you talk about, okay, who can talk to what? And then you have another spreadsheet for the networking and firewall. And anyways, some poor person has to go through all of these and set it up, right? And what happens in the end? When you actually have all the environment up and running, you deploy the app, like 20 minutes later, you go try it, what happens? It doesn't necessarily work, right? Why is that? It's because the configuration is radically different between different environments. With Kubernetes, what we're doing is to say, every machine here looks exactly the same. The way you configure your application is exactly the same across multiple environments. Rather than looking at each of the machines individually as something that we have to manage and upkeep, we see the entire cluster of machines, the entire cluster of these resources that we have as a single unit, right? So rather than a single operating system scheduling an app in that single machine, Kubernetes is really like an operating system for your cluster where you can say, go run this app, and Kubernetes can help you determine where to run it and set up all the behind-the-scenes infrastructure for you. Okay. And ultimately, what I really like about Kubernetes, and I'll show you this in a second, is that rather than thinking about what that infrastructure, how we need to upkeep the infrastructure, right, by writing a lot of a script around maintaining that infrastructure, we spend all of our time literally just writing the code to do something for the user, right? Because a lot of the times we think about, okay, what happens if the application restarts, right? Well, you need a script to restart it. Or if it crashes, you need something to help you restart it. You have to detect that. If the health check fails, well, you need something to check the health check. But you have to do a lot of those yourself, potentially. With Kubernetes, basically you forget about that. That's all provided by the platform, and we just write the application, and people can use it. And a prime example of this, this is my own example really. In March 14th, that is Pi Day. How many people know or celebrate Pi Day? Yeah, that's pretty cool, yeah. So 3 days before Pi Day, 3.1415 days before Pi Day, we said, we got to do something. We always do something for Pi Day. And so we brainstormed with my colleague, Francesc, Sandeep, Ian, and Guillaume, actually, Guillaume LaForge. And we decided to make a website. This is a Pi Day website. But that's not it. The important thing here is we actually made an API for Pi. Okay, so this is a fun thing. So you can actually, today, right, just for fun, you can say, hey, go to the Pi API, and you know, give me the 300,000 whatever digits, and I can give you the Pi. We have about 750 billion digits in our database today, and you can use this API to query it. And we literally just spent like an evening to write this app, and then we deployed everything in Kubernetes onto like 30 nodes, really, without having to do any setup ourselves, right? And what's even more fun is we did a load test, and just between the two of us, we're like, okay, I wonder how much node we can take, and within like minutes, we're able to spin up test loaders in Kubernetes as well, and we're able to hit 4,000 QPS, which is not bad, right? It's a decent number. And we say, okay, let's go live, and that's it, right? So at no time did we actually go into the machine and set them up ourselves. So that's what I want to show you today and see how we can take this to a global deployment, all right? So how do we get started? Typically, when you think about Kubernetes, people think about at scale, which means, I don't know, more than one machine. Okay, you say you have a cluster of 2 machines, you need the cluster first. But as a developer, we need to get started from our laptop. And there's a really good tool that you need to use for local development. I will highly, highly recommend it, and it's called Minikube. Basically, it is a VM that you can, it's a command line utility that you can use. You can just say Minikube start, okay? And it's going to download the VM image for you and set up Kubernetes inside and set up all the endpoints for you, and you can just start using it. And everything will be running locally, okay? So let me start from there. So I have an application here. I'll show you what that looks like in a second. Basically, the application is this, right? There's a little button I want to press, and it talks to a service behind the scenes that will give you a random message, okay? It's very simple for now. But how do we actually deploy these 2 components in, with the style of Kubernetes? How do we actually do this locally to get started? Well, first, we need the app. And I have a backend application and a frontend application. Okay. Now, I actually wrote the application in Go in this case, but it doesn't really matter. You can write it in Java. At the end of the day, what you need to do is to create a container. You have to create the container image that can run this app. So let's do that. So here I have the application written in Go, and I have written a Docker file that will do the compilation for me, and it's using Go 1.3, for example. And I'm just going to go ahead and build a Docker container. Okay, so I don't know if I have this queued up. Yeah, there we go. So I can say Docker build -t, right? And this is the backend, so I'm going to do that. And that should be able to build the container for me. However, before I run this command, what I want to make sure is, well, wait a second, where's Docker running, right? Everybody has Docker running locally somewhere, right? And actually, if you have your own Docker daemon, you can just build this, right? But if you're using Minikube, Minikube actually has a Docker daemon running inside of the VM as well. So I really did Minikube start, and I can say Minikube status, and that should tell me I'm up and running. And what I can also do is I can get the Docker environment for Minikube. So there's a VM running Minikube, running Kubernetes, and also Docker daemon on the same VM. So you don't actually have to run another Docker daemon separately from this one, okay? And in order for you to use it, you can do eval. Actually, let me just copy that and do that. What that's going to do is set up this, this session, this bash session, to make sure that whenever I type the Docker command, this is actually talking to the Docker daemon inside of Minikube. Okay. Now, if I were to do the Docker build and do the backend, what this will, oh, that was fast. That was a little bit too fast. I don't know if that worked. When things are too fast, I don't know if it worked. All right, we'll see. All right, so I do a Docker build, and I give it the name of the image, and I build the Docker file from this context. What happened behind the scenes is I'm actually building that image directly in the Minikube VM. Okay, and I can also run it if I want to. So I can say run that, right? I can run it. But in case you're wondering at the beginning, if your space gets used up all the time, and after 3 weeks, and you're like, hey, Docker took up all the spaces, well, start running it like that with --rm. What that will do is to remove the image for you after you run it, after you exit. Otherwise, it's going to be there forever, right? So now we can run this backend. It's up and running pretty fast. It's listening on port 8080. What we can also do is to bind this to a port. Let's see here, P8080. So I'm going to put it on 9090. And I'm going to, so 9090 will be the host port. I'm going to forward the host port to port 8080 in the container. By the way, this is just pure Docker right now. And then with Minikube, what I can do is I can say Minikube IP. That will get me the IP address of this VM. And with that, I should be able to see 9090 and API next. That's the endpoint. And I'm able to connect to that. So that's perfectly fine, yeah. So I'm using Minikube literally like a Docker machine at this case. Okay, let me go ahead and do the same thing for the front end as well. So I'm going to build it. And I'm going to code this the front end. That was also a little bit too fast. Okay, so let's see if I can run this one. I should be able to. So I can say docker run, TI-RIM, and let's see. Actually, I'm just kidding. This is working. It's running Nginx proxy, and there's no output. And just to prove to you that was right, 9091 to port 8080. 80. Oh, wait, what's going on? Oh, I say, there we go. What? Oh, there you go, -p. Okay, so get the Minikube IP again, and if I go to 9091, and there's my app. Okay. Now, if I can, of course, if I want to, I can use Docker Compose. So here in my directory, I have a Docker Compose file. I don't know if anyone here use Docker Compose locally. I like to use it just so I can tie up everything together pretty simply. So I can run both the back end, right, and the front end together. And I can say Docker run Docker Compose up. And I should have both up and running. And I think that 1990 will be my front end. Yeah, very good. And, oh, that doesn't work. Right? So what is supposed to happen is that when I click on this button, it should be able to connect to the backend to talk to it. But why is this not working? Well, actually, because this microservice is actually exposed as a RESTful service, this is really just a shell front end that's making the call via the API, via AJAX, to grab back the response. And if we look into this closely, and I'm sure a lot of people do this today, is that if you send a request, it's actually gonna try to go to the same URL, the same IP, right, the same port, / so it's a relative path, right, to your app. What do we typically do in this case when you're running microservices yourself, right? If you have 20 microservices you want to expose publicly to the app, what do we do? What's that? etcd? Not quite, so close. A lot of people, what they do is they run what they call the API gateway, right? Does that ring a bell? Right. So what people do is that they need to front the front end and the back end and expose it in a single, in the same domain name, so that you can make the call relatively. Otherwise, you have to deal with CORS, you know, the cross-origin policy stuff. That could also not be very good. So what people need to do is to front some of these things in front of a load balancer or an Nginx proxy or an API gateway of some sort, like Zool. Now then you say, okay, what do I do now? I got 2 containers I just want to run, but now I got to deal with API gateway. All right, so then what people do is, oh, shoot. we go to Docker Compose potentially, and we say, okay, now we have to run another thing, maybe the API gateway. We gotta configure it with whatever configuration we need to do. And now we have 3 components we have to manage that will then route the traffic for you, right? Let's see how we can do this in Kubernetes. Right? So in this case, this is a visualization tool. In this case, we only have 1 node, right? Because we're running a VM. This is a single VM. What we can do is there's a little thing called, if I go to here, there's a little utility called compose with a K. Okay, so before we did the compose, Docker compose, there's another utility called compose. And I can actually convert the file from my Docker compose file. And that will actually generate the corresponding configuration files I need to run in Kubernetes. Okay, so you can actually deploy this as is, everything will just work. But I don't want to do it that way for now. What I want to do is to show you the simpler way for developers to get started, which is to use the command line called kubectl run. So I can go ahead and say kubectl run, the name of the application. I can name this whatever I want, and I can give it the name of the image, which is button masher frontend, which I just built. Okay, and then I can give it labels. This is important. Labels is very, very important in Kubernetes. Everything you run, every application you run, every resource you create in Kubernetes will have a label of some sort. And label is really just key value pairs. In this case, I can name it the app is equal to the front end, for example. I can give it version is equal to 1. Conference is equal to DevOps. Friends, I can say staging is, I don't know, prod, right? So it's just key value pairs. What's important here is that you get to pick and choose what you want, but at the end of the day, you can query it. So you can say, hey, Kubernetes, can you tell me everything that's running in the production environment that has the name button masher frontend that's of version 1? And Kubernetes will say, yeah, we have 3 instances. There you go. Right? But in this case, all I'm going to do is to say just the name of the application and whether I want to see it on the visualizer. So I can do that. And there you go. So what happened here is that, which is 1 command line, I told Kubernetes to deploy my app with 1 instance, and that is this instance right here in the gray box, and it's up and running. Now, because I also built my container image in Minikube directly, what that means is Kubernetes doesn't actually have to go out and fetch it again. So, when you're running this locally on your laptop, you can just build your container in the VM, and you can just run it directly without having to go out to the internet to fetch it back. Okay. And we can also run the same thing for the backend. kubectl run. Let me see here. So that just running the backend with the backend image. Okay, so we can do that. And that should be running down here. Yeah. So now we got frontend and backend running, which is kind of like, okay, I could do that with Docker. That's pretty easy, right? But then what do? You can actually now scale, even with 1 VM. So you can simulate pretty easily how many, if you have 2 instances, if they need to be clustered together, what do? Right? So you can say scale deployment, button masher backend. I can say, give me 2 instances, and that should scale it out. And now you have 2 instances running. Kubernetes manages all the port mapping behind the scenes for you, so they will never have a port conflicts, for example, because they're running in containerizing environment. And if you notice closely here, every one of these instances also gets their own IP address. Okay. So what that means is when you're running this instance, you're running on port 8080, but that's bound to this IP. And another instance will be running on another IP address, so you can actually bind to the same port. Now, if you have multiple of these instances, how do you actually get access to it? What do you do, usually? Right now, you have 3 instances. I mean, imagine simulating this yourself on a laptop without orchestration. That's pretty tough. I had to do that before, right? I had to do IP aliasing. I have to manage my own port, and I got set up a load balancer, right, to simulate and route traffic to everything. In Kubernetes, load balancing is actually first-class citizen. What that means is I can actually create what we call the service to become a load balancer that can sit between these two instances of the application. So to do that, I can say kubectl expose. That's the command line we can use to create a load balancer. And what this will do is to expose my front end and route from the port 80 to port 80. So you can literally change this, right? So just like when you say Docker run, you can bind the port from the host port to the actual container port. This is the actual container port right here, and this is the port that everybody else should be using. Okay, so I can do that, and then I can also expose the backend as well. Oh. So I say kubectl expose deployment button masher backend. The target port is 8080, and I'm going to expose it on 8080. And here in Minikube, I'm going to do something special. I'm going to also expose the application on the actual node. And the node is actually just the VM itself. Okay? So now I have created a load balancer that will front the 2 instances I have for the backend. And I got a load balancer that can front the front end, which only has 1 instance. However, how do I get access to it? If you actually check the service, we will be able to see that the backend service routing to port 8080 can be accessed on the node port on the machine on 30452. Okay. So essentially what you can do is to get to that IP, and you can use this host port to access your app. Okay. And this is a backend, so I can say API next. Right. But this requires you to actually look it up yourself. Now in Minikube, the easier way is to just say Minikube service and give me the button masher front end. And that will actually open up the front end for you and route it to the right port for you automatically. It's pretty cool. However, oh shoot, that's still not working. Right? Why? Because I still haven't dealt with the proxy yet. I haven't dealt with the API gateway. Right now in Kubernetes, we don't call it an API gateway. I mean, it's really not a first-class concept in Kubernetes today. But what we can do is to give you what we call the ingress. So this class of problems can be boiled down to a level 7 mapping for your URLs. It's more like, well, where do I actually map API next? What service do I map that to? And what do I map for the root and everything else? So in Kubernetes, what we can do is to create an ingress, and this is actually the concept that will then be mapped to an actual load balancer that's L7. So that's a HTTP load balancer. In this case, we can actually define an ingress definition to say, hey, by default, I want everything to be routed to the front end. That is the service that we just created. And then for the API call, next, I want to route that to the backend. And the port I'm going to be calling on these 2 instances is port 80 and port 8080. Okay? And what this will do in any environment that you have ingress support for Kubernetes is actually to create a real HTTP load balancer for you. Now, because we're running in this mini environment with just 1 node, Minikube can actually deploy this ingress for you as well. But first, we have to enable it. So we can say, there's a bunch of add-ons you can add in Minikube. So we can add ingress. You can also add registering here. You can have hipsters. You can monitor how your application is doing. We also have a dashboard that is deployed by default, for example. So I can say Minikube dashboard. Okay. And oh, there we go. Hey, I don't want that. Hold on a second. I need to be here and then Minikube dashboard. Okay. Come on. There we go. Almost. Why is this not opening? What is going on? Anyways, that should open up somehow. No, don't want to open? I guess not. Not today. I guess it was really mad at me for closing the previous browser window, so I'm not quite sure what happened. But let's just say we have add-on where I want to enable the ingress. So I can say add-ons enable ingress. Okay. What that will actually do is to deploy Nginx for you into Kubernetes to act as the HTTP load balancer. And then you can actually apply the ingress configuration. Oh, let me see here. kubectl apply -f button ingress. Okay. And what that will do is to actually configure the load balancer for you, and now you should be able to, once everything is up and running, you should be able to go to the actual load balancer IP address, go to port 80. Now, rather than having what we call a network load balancer, now you have a real HTTP load balancer. So let's see if that works. Okay? Oh, that was too fast. Okay, that's scary. Okay, so that works. So now I'm looking at the load balancer. This is the ingress. If I click on this, it's being routed to the right backend. Okay, so rather than having an additional component for you to route all of your path to the right place, you can actually just manage all of that within Kubernetes as well. So far, so good? All right. So now I have all of my application prototyped in my Minikube environment. This is not a production environment by any means. How do I actually get it to a real environment? Okay. So for that, I have another cluster I set up already that's actually set up on Google Cloud Platform today. But then remember, Kubernetes can run everywhere. It can run this on-prem. You can run it on the cloud. It doesn't matter. So let me go ahead and switch over. So in Kubernetes, what I can do is I can set the configuration to use a different context. A context is really just where is the cluster and what credentials do I use? So rather than using the Minikube context, which is I'm using right now, I'm going to switch over to a context that is actually in the cloud. And once I've done that, let me show you what that looks like. If I go to the visualization tool, I have four nodes in my cluster now, rather than just one. And these are production-ready nodes. And now I can deploy the app over. But how do I do that? Well, let me see what's in Minikube context, right? I have a service. We created two services, right? These are the service. And then we have the ingress. These are the environments that we are dealing with. And then we have deployment. Okay. So deployment is just my application. I'm running two instances of the backend and one instance of frontend. What I want to do now is, how do I get this environment into production? Well, there are two ways of doing it. I'll show you the easier way, and then you can go from there to make it even better afterwards, right? But this is what you can do. Get deployments. You can output it as a YAML file, okay? So if we do that, you get all the configuration that was generated for you behind the scenes. You can just output that. And then you say export, so it's in exported format. And I'm going to dump this into deployment. Okay? And then I'm going to do similar things. So I need to talk to Minikube. I'm going to say get service. And I have the button masher front-end service and the button masher back-end service. And OYAML and -- export. And I'm going to dump it into service.yaml. Okay. Now, you cannot really use it right out of the box, unfortunately. But I will go through it to clean it up. But you should clean up a few things here just to make it look nice. Like that, you don't need. You need to remove a few configurations, right? But after you have cleaned it up, it's pretty much ready to go. So for example, here, I don't need the creation timestamp. I don't need the self-link. And I got rid of the IP address that was sent to me, so I don't need that. And that's it. For the deployment, let's see what that looks like. Deployment. Oh. Let's see, here we go. Okay, for the deployment, we have all these annotations, which we don't need. Creation timestamp, we don't need. Resource version, self-link, UID, we don't need. But what's important here that you do need is really just the image, right? So this is, remember we ran the kubectl run? It actually generated all of these configuration for you behind the scenes, okay? But if you don't want to write this by hand, you can just export it, and then you can actually reuse it in later. So I'm going to get rid of a few of these things that's not necessary, like status and all that. Annotation, creation, generation. No, don't need. Resource, no, good. So once we have sanitized the YAML file, without the status, especially the status, I don't want that at all. We exported it from our running environment, and now, if I use the context properly, I mean demo, what I should be able to do is to say kubectl. I can actually deploy these YAML files. I can deploy the same app. So what I can do is say kubectl apply -f, and let me do the deployment first. That's usually the one that works. There we go. Done. Right? So we literally just took the exact same app with the same configuration we just port it over into our production environment this way. Okay. And same thing with the service. We can do kubectl, apply F, and the service configuration. And again, without doing much work at all, this is running a real cluster. We just took that configuration, and it's now running on Google Cloud Platform, right? And you can do this for another platform as well. It doesn't really matter. And what about the load balancer? Well, we apply this ingress that we have configured. We can also apply the ingress, but the work to do that is slightly a little bit more. Depends on the cloud that you're on, right? So for example, in a production environment, I don't want my IP address to change all the time, right? If I have, racecompany.com, I don't want that IP to change all the time because then I have to change the DNS all the time. So what I need to do first is to create a reserved static IP address that I can potentially use. And then I need to, let me see here. There we go. And then what I need to do is to enable firewall rules so that people when they go to my domain name, their traffic can be routed through a load balancer that is actually being managed for you. So I'm gonna wait for this. This takes a little time. Okay. And then once all of these things are done, then what I can do is to create the ingress in the cloud environment with exactly the same configuration. Okay. Now, you have to sync this in a little bit, right? Because I'm going to run this exactly the same way, so I'm going to say apply ingress. Notice how I'm doing everything exactly the same way as I was doing in Minikube. In fact, you will be able to do this exact same thing if you run this against another cloud or another environment. The beauty here is that Kubernetes is an abstraction for you, regardless of how big the infrastructure is behind the scenes. You do exactly the same thing no matter what your environment is. You can run this in potentially, say, an OpenStack environment. You can run this in a bare bone environment or in the cloud. It doesn't matter. Okay, so let me see, get ingress. So that what happened just now is that because I deployed the ingress now in the cloud environment, what's happening behind the scenes is we're actually going to Google Cloud and say, give me a real load balancer. And that will be provisioned for you automatically behind the scenes. So no longer do you have to go into our console manually to create it, for example. And if you deploy it again in another cloud, it will actually do all the work for you behind the scenes. And this will take about 5 minutes to set up. Oh, there we go. I already got the IP. But then it's going to take about 5 minutes for everything to be connected together. And now you have just deployed the same app in a cloud environment. But that is not where we can stop, right? Because we started off with a laptop. Then we went to a cluster where we do see entire pool of resources as your single one. And not only do we deploy the app, we also deploy the architecture as well, because not only do you have the runtime, you also have the load balancing in front of it as also. But now, what do we take from here? What we can actually do with Kubernetes today is to go one level beyond and see multiple clusters as one. Now that's really powerful. This is what we are seeing today, right now. So what I just show you is that I have this control plane, which is the API server. So whenever I do a kubectl command, it's actually converting it into a RESTful call, and it calls a control plane API. And the API will then receive this request and say, OK, let me go and talk to each server individually for you. So through the API, through the CLI, through the UI, we can control an entire cluster. So then we stood back a little bit and say, well, how do we actually manage multiple clusters in this case, right? This is a single cluster. If we want to manage multiple clusters, then we can introduce another control plane in between all of the clusters. So literally, this is what it looks like behind the scenes with Federation. So with the same API, with the same client, with the same tooling, you can talk to what we call a Federation control plane. And through that control plane, it can then go ahead and talk to multiple different clusters that's running Kubernetes. And it does not matter where they run. For example, the first one runs on Kubernetes on Google Cloud. The second one runs on Kubernetes on another web services cloud. And the third one runs on-prem. It doesn't matter. Through their control planes, each one of them will then talk to their own cluster. That's how Federation works behind the scenes. So what that means is I should be able to take that exact same configuration file that I just deployed on my laptop to the cloud. I can take that exact same configuration file and deploy it to the world across multiple regions in this case. And the way that it works behind the scenes is that you first need to set up the control plane on one of the clusters. So if I have like 4 clusters running across the globe, in the US, in Europe, in Asia, I need to pick one of those clusters that I got, and I'm going to make that into the Federation control plane. And I can deploy the API server into that. And once I have done that, then what I can do is to join. So I can use a utility that will then join multiple clusters into this federation. And now this control plane has access to multiple clusters through a single API. So now I can code exactly the same command like kubectl apply, kubectl create against the control plane API. And if I want to create a service, this is what we call a federated service, it will then, on my behalf, go ahead and reconcile this state with multiple clusters behind the scenes, right? Does that make sense? And not only that, once the service is up and running, it will also update the DNS for you, which is incredible. So suppose you have 3 different regions. They all have an IP address exposed. Rather than adding all of those IP addresses individually yourself manually into a single DNS entry, we will actually update the DNS entry for you behind the scenes as well. Same thing with applications. If I want to deploy my app, like the backend app, I can just say kubectl create or apply the deployment, and through the federation, we will be able to deploy it into multiple clusters and behind the scenes onto multiple computers, right? And then also we'll update the DNS entries for you, which is pretty cool. Okay. There's one last thing is for the ingress, we can also deploy the load balancer for you. In this case, we'll actually deploy a global load balancer where we can then route the traffic through a single entry point for you to go to any one of these regions that actually has your application running. Okay. Now, there's one thing that you have to worry about, which is what we call one of these things, which is cross-region communication or cross-zone communication, right? In a region, typically within a availability zone, you have a really fast network. In a same region, across multiple AZs, you also have decent network because they're pretty much physically located together. If you're going across regions, then you have issues. If you're going across region from Asia to Europe, you're going to introduce latency. So in Kubernetes, we can actually do cross-cluster load balancing in federation. What that means is, where we go, we actually know potentially where all the clusters are physically located, or based on the name of the region that you're running in. And if your backend is running in that region, we will automatically route the traffic to that backend. And if that region actually fails, right, or that backend is not running there anymore, then we will actually automatically forward that request via service discovery to a region that's closest to you. Okay. And the best way to demonstrate it is that, let me see here, let me get ingress. This is the last thing. So I'm going to go to this URL, hcr.ks.io. You can actually go here right now if you want. And actually, I do encourage you to go because right now I have one application running. Okay. So if you click on this button, we should be able to see the QPS. Right. So if you go there, you can generate QPS just by clicking the button, or if you want to hack it, you can write a while loop if you want to, right? So you can hit this URL as much as you want. What's happening behind the scenes then is, let me go ahead and do this. Okay. Apply. So I'm going to, rather than talking to my cloud cluster, what I can do is to use config, use context. I'm going to use the federation cluster now. Okay. So now I'm talking to the federation server. And in this federation server, I have control over multiple clusters in Asia, in Europe, and in Central. And I can also say, let me go ahead and deploy this app. I got another YAML file I can deploy. So I can say, go ahead and deploy button measure v1. Okay, so I got that. And then I'm going to also deploy the load bots, right? So what the load bot can do, oh, sorry, there you go. What this deployment is doing, Sorry. Not enough room. Okay. Why? Okay. So what this is doing is this is another deployment. This is really just an application that will generate request, and it will generate request against this DNS name. This DNS name is actually the federated DNS name. What that means is, again, this DNS name will resolve to the closest IP address for you that has the service running. Okay, and it's going to hit port 8080 in this case. And when this is running, we can actually see each one of the instances is generating 1,000 QPS, and now we're generating 3,000 QPS in total. So we're generating the request from Asia, 1,000 QPS, but there's nothing running in Asia, so it forwards the traffic to the US. It's generating 1,000 QPS from Europe, but there's nothing running in Europe, so it's doing the cross-region load balancing, so it's actually coming to the US as well. And in the cluster, I can also get the deployment. Almost done here. So right now I only have one backend running, and it's running in the US. I can simply tell the federation to scale it. So I can scale the deployment just like what we have done. And we can say replicas is equal to, let's just say 6. Okay. Now this is really, really cool. We need to schedule 6 instances of the app. We have 3 regions. So technically, if we spread this out evenly, we should have 2 instances running in each of the region. And you can see that we actually have 6 instances running. And the service discovery should kick in pretty soon. There you go. And you can see now, because they now know you have application running locally, so rather than going across the ocean to the data center, it just goes back to its own. And this is without any additional changes in the code. It just works magically like that. And we can also, at the same time, this is even awesomer. I'm almost done here. I can also do what we call rolling update across multiple regions globally with Kubernetes Federation. So I'm going to go ahead and deploy the version 2 of this application. Let's see how this works. Almost done, pretty much done. And let's see, I just want this to deploy. So with rolling update, what we can do is we can replace an instance of the old application with a new one. And we can do this in a cluster pretty easily, but we just actually done this, it just finished across multiple regions. So this actually happened across multiple data centers through a single command line, because Federation controls everything for you behind the scenes. Okay, so if I were to go, this is the last thing, and click on this button, now everyone should be getting, V2. And one last trick up my sleeve to show you, If I go to see the load balancer, hold on a second. If I go to the networking, and if I go to load balancing, hopefully this is going to show up. If I go to monitoring, so this is where I can see where the traffic is coming from. And if I go find the backend here, oh, not that one. Let me try this one. Oh, no. No, that's too bad. But when this status catch up, what this will show you is that because we're physically located in Europe, we actually route all of the European traffic directly into the European data center. At no time do we actually go to other regions unless if it's being overloaded. So that is what all I got for you. And you can actually find all of the code and the Federation code and also the demos directly on my GitHub. And the visualization tool you can also find. You can actually set this up in about 10 minutes across multiple regions if you want to try it on Google Cloud. And there are a lot of things we can federate. So you can literally just deploy, send out your configuration globally to your clusters over the world, and hopefully it will make it really easy for you. So thank you very much for your time. I really appreciate it. Yeah, thank you.